All right. Good morning, good afternoon, good evening. You are welcome to today's session. We are going to be handling a very important question related to relative density, and it is called density mixture. Okay, I'll be breaking it down. Please, if you are new to this channel, kindly like, subscribe, and you can turn on the bell icon. That's the notification bell. It will notify you whenever we drop a video tutorial. All right, so today we're going to be talking about density mixture. So right about now I'm going to be bringing out the question that we are going to be handling in today's session. All right, so hang in there, guys. Let's go. Okay, so welcome back, everyone. So this is the question. It says 40 meter cube of okay, I'm just going to go ahead here and write question. All right. It says 40 meter cube of liquid P is mixed with 60 meter cube of another liquid Q if the density of liquid P and Q are 1.00 kilogram per meter cube and 1.6 kilogram per meter cube. What is the density of the mixture? Very simple. Now please mind you, whenever you see questions in physics, the first thing I'd like to tell you and all my students is that don't panic. Every questions are being produced from somewhere. There is no question that falls from heaven. Every question were produced from somewhere before. All right, so what you do is this: look at the question carefully and narrow the question to where you think it was being set from. All right, like this particular question now, density mixture, it is from the topic relative density. All right, so if you want me to create more videos on relative density, let me know in the comment section. All right, and meanwhile, don't forget to subscribe, like, and share. And if you want me to continue this particular topic called relative density, kindly let me know in the comment section, because I'll review in the comment section. All right, let's go. It said 40 meter cube of the liquid P. Now, from the statement here, if you analyze it carefully, you will observe that we are having two liquids here. The first liquid is liquid P. This is it. Let me underline it. This is the first liquid P, and this is the second liquid Q. All right, the first liquid P and the second liquid Q. All right, now I'm going to go ahead and write solution over here, and I will draw a line separating the two liquids. All right, this is liquid P, this is liquid Q. All right, so I'm going to write out everything about liquid P under here and everything about liquid Q under here. 40 meter cube of liquid P. So the volume of liquid P is what? 40. All right. Is mixed with 60 meter cube of another liquid Q. So the volume for liquid Q is what? 60 meter cube. Okay. If the density of liquid P and Q are both this and this, that's 1.00 kilogram per meter cube and 1.6 kilogram per meter cube. So which means this first one that was mentioned is for P, while the second one that was mentioned is for Q. All right, so this one is for P, this one is for Q. Okay, so on that P, I'll write the first one, which is what? Density. I like to use D for my density. I don't like using, some people like to use P like this or P. I just like using D for my density. All right, so for P now, the density is this, because it said if the density of liquid P and Q are this and this. So this first one you're seeing here is for liquid P. So 1.00 kilograms per meter cube, and then the second one. All right. So the density for Q now is 1.6 kilogram per meter cube. All right, that's the density for what's it called, Q. Now when it comes to solving questions in density, when it comes to solving questions related to density mixture, one of the major formula that is only needed, okay, I'm not saying the word only because there are different diversity of questions. The major formula that is required that is required to solve questions related to density of mixture, it is this formula called D is equals to mass over volume. That's density is equals to mass over volume. All right. This is the major required formula. Density is equals to what? Mass over volume. This is density, this is mass, this is volume. All right. So now for P, I have volume, I also have density, but I don't have mass. You see that now? For Q, the same thing. I have volume, I have density, but I don't have my mass. So what do? I will simply go and look for the mass for P. I'll look for the mass of Q. All right. So let's go ahead and look for the mass of P. Okay. Remember, for P now we are using the formula density equals to what? Mass over volume. For Q, we are using the same thing. Density is equals to mass over volume. Now, let's get on with it. Let's start solving based on the values we have. Now guys, look at this. I'm going to be working with the values I have here inside of here now. Okay, so density is what? 1. You can just use 1, remove those 0, 0, 0, equals to what is the mass? We don't know. I'll leave it there as the mass. What is the volume? Volume is 40. All right, so what will I do next? I'm going to go ahead and cross multiply. Look at the arrows, look at where they are pointing towards. This figure, this letter here, will go and multiply here, but there is nothing here for it to multiply. So bring M down here as M. All right. Why 1 here? We're going to multiply what is here. So it becomes 1 times 40. So M is equals to 40 because 1 times 40 is 40. Let's start for this side now. D is equals to what is the mass? Okay. I think we already have the D. All right. The D is 1.6. So I'm going to go ahead and I'm going to stroke this now and put 1.6, all right, equals to what is the mass? We don't know the mass. All over what is the volume? The volume is 60. Okay, so I'm going to cross multiply right now. All right, there's nothing here for M to multiply. Okay, so break it down as M equals to then 1.6 times 60. All right, that will give us, okay, now say 1.6 times 60. Okay, M is equals to, that will give us 96 kilograms. 96 kilograms here is also kilograms. So I've gotten the masses now. I've gotten the masses for both P and Q. Remember, we are looking for the density of the mixture because from the question they said that the liquid was mixed. Let's go back to the question so you can get the entire concept of what I'm trying to explain. It said 40 meter cube of a liquid P is mixed. Can you see the word mixed? Is mixed, which means they were mixed together. Is mixed with 60 meter cube of another liquid Q. So which means P and Q, they were mixed. How do you mix something together? You plus them together, all right? So what I'm going to do right now, I'm going to add up my volume. I'm going to add up the masses. Now, I just got the masses as 40 for P and 96 for Q. Now, they said it was mixed. So let's mix up the masses now. So I'm going to see masses. Okay, so masses mixed. That means we're going to mix up the two masses now. So these are the two masses. Let's mix them up because it said that liquid was mixed. So 40 plus 96. That will give us 136 kg. This is the mass that was mixed. Now, since they said they mixed the liquid, which means everything was mixed together, including the mass, including the volume. All right. So now, let's talk about the volume now. Now, this is the volume. The volume. All right. Now, let's mix up the volumes now. All right. So, volume mixed. Okay. Now, volumes mixed. So, the first volume is what? 40 plus the second volume is what? 60. So 40 plus 60, that is what? 100 meter cube. So we have our masses mixed and we have our volume mixed. Now, what are we being asked to find? Density of the mixture. Now, please, you are not mixing density. You are not mixing density. Okay? You are not what? You are not mixing density. You are only mixing the masses and you're only mixing the volumes. You are not mixing density. All right? Yes. Now, we are looking for the density of the mixture. So which means we are going to be working with mixtures. When I talk about mixtures, I mean we are going to be working with what has already been mixed. These ones now, they have now been mixed. So this is now the new mixture of the mass. You get now? Like the masses has been mixed. Let me now go and cancel this thing, please. I hope you can see it. 136. So these two were mixed together to form this. This is now the overall mixture, the overall mass mixture. These two volumes were mixed together to form this. So this is now the overall volume mixture. All right. Now they're asking us to go and find density mixture. So how do I now get density mixture? You will get density mixture by using the mass mixture and the volume mixture. All right. So let's go and get density mixture now. All right. Let me take my camera here. Yes. Density mixture now. All right. So I'll say density remains mass over volume. All right. That remains the formula for density. So density mixture is equal to, what was the mass mixture? The mass mixture, don't forget, it was 136. That was when we plus 40 and 96 together. That is the mass mixture, 136. All over, what is the volume mixture? The volume mixture is what? 100. So 136 divided by 100, that should give us 1.36 kilogram per meters cube. So density mixture is equals to what? 1.36 kilogram per meters cube. So guys, this is how to solve questions on density mixture. Let me do a quick recap on everything I just said. All right. So first of all, this was the question. The question says 40 meter cube of liquid P is mixed with 60 meter cube of another liquid Q. So they were mixed. So I wrote out everything they gave to us on P. I wrote out everything they gave to us on Q. So I went to look for the masses of each of them. When I found the masses, I wrote it out. The mass for this one was 40. The mass for Q was 96. So they said that the liquid was mixed. So which means we are going to be mixing their masses. So we mix their masses together, 40 and 96, to get 136. And we mix their volumes together, which is 40 and 60, to get 100. All right. So we have gotten the mass mixture and we have gotten the volume mixture. All right. So after we got this, we now came over to find the density mixture. All right. With our formula, density is equals to what? Mass over volume. So density mixture is equals to the mass mixture over the volume mixture. What was the mass mixture? 136. What was the volume mixture? 100. So I divided and I got my answer. So guys, that is it. If you want more questions, more content on relative density, let me know in the comment section. Don't forget to like, share and subscribe. See you in the next tutorial video.